Hello students, in this video we'll discuss about parser generator called Yacc, yet another compiler. So the last topic we have discussed about how to deal with the ambiguous grammars with the modification of grammar and handling in the table directly, right? So see, we are in second phase of compiler, right? The first phase is lexical analysis. You can implement in two ways. We have discussed in the last video of the first unit that you can write your own handwritten code or you can use the tools like Lex. Same way, if you want to generate the syntax analysis for your compiler, again you can do it in two ways. By using your own code, you can write it, or you can use the existing tools available in the market like Yacc, yet another compiler. See, to generate the LRK parsers, we are going to use Antler tools also. Of course, not only this, whatever I listed out here, there are so many other tools available in the market. So then, but this is the yet another compiler. Compiler is the most popular one because it is going to generate the most widely used parsers, LALR. See, CLR is most powerful, but LALR is most widely used because of its size and cost complexities, right? So, and we have another improved version of Yacc also that is called Bison. But in this, we are going to discuss about Yacc only, yet another compiler. Like Lex specifications, even Yacc also having the three sections: declaration part, translation rules, and of course auxiliary procedures. What do you want to write it? So same like translation declaration part, you have to specify what you are going to use in our Yacc file, and if that is matched, what we have to do, that you have to specify in the rules. And in auxiliary procedures, we have to call the appropriate procedures, whether it is C language or Java where you are writing it. So that procedure you have to call just like the Lex specification rules. So for example, the translations, if you have a production like S tends to XY, and what is the action you have to perform, what it has to be done, whether you have to update it, whether you have to derive it. So what you are doing it, that you have to specify here, right? So let me just go through with productions. See, if you are having a non-terminal, and what is the token we are doing, and what are the other non-terminals it is calling, and what is the action we have to take it, right? So here tokens means any single characters like plus, then it is going to give a token name. So percentage token, and what is a token name, and when it is detected, what you are supposed to do, that you have to specify in this, right? Assume that guys, you want to generate a parser, LALR parser. Then what you have to do, first you have to open a Yacc tool, right? Then the extension of that file would be yacc.y. Like when you open a C editor, the extension of the file is noname.c or program1.c or demo1.c by default. Same way, when you open a Yacc file, by default you are going to have called yacc.y. .y means Yacc file. So, and by default it is going to have the three sections by separating modular operators. So this declaration, translation, auxiliary, you specify what you are going to use, what are the non-terminals you are going to use, what are the terminals you are going to use, how many productions, that you have to specify. Do you have any escape characters? Then in translation, if this non-terminal or token is detected, and what is the action you have to specify? Which procedure? For example, you are saying that update symbol table procedure, right, or derive a non-terminal procedure. Then what is the code for it, that you have to specify in the auxiliary part. Like everything you have to specify. For example, if you're having arithmetic operation expression grammar, E tends to E plus TRT, first you have to specify the declarations. Then if place is detected, what you are supposed to do, take the value of first identifier, second identifier, do what exactly it has to be done, action. Okay, so in detail of these actions we'll discuss in the SDTs, that is next unit concept. You'll come to know about it. Just assume that when place is detected, some action has to be done, that we have to specify in this auxiliary part. So like that, how many grammars you are using in your compiler, that all you have to specify here, And if a particular token is detected, what you are supposed to do, that everything code you have to write it. So once you are written this, then your Yacc file is ready. Then save it. And I assume that you are writing the compiler code in C language. Right, new compiler called Mac, like C compiler, I'm writing Mac compiler, like Java compiler, I'm writing Mac language, then I've written. So by using the legs tool, I got the lexical analysis by like la.yy.c, I got the lexical analysis complete code. Now to get the syntax analysis, I've opened the Yacc tool by writing the .y file. Then I'm giving it to the Yacc compiler. It will give you the y.tab.c. Now I can take it y.tab.c. Now syntax analysis is also ready. Before incorporating into your compiler, if you want to check whether this file is working fine or not, you take the .c file individually and compile with the C compiler. It will give you the executable code that out. So if you produce some input to it and it will check, like for example id plus id star id, you give it to it, so then it will tell you whether it is syntactically correct or not without writing all thing whatever we have done in the previous videos, like constructing table and everything, because that would be taken care by whom? YACC, Yacc generator. Just you have to specify the grammars and rules, tokens, procedures, like that. You don't need to worry about the tables. The tool will take care about the table, but you should have idea, because for example if you are writing new programming language, you may not have the tools for it. For C we have, for Java we have, Python we have. For example, you are writing programming language in C# or some other new programming language, what happens? You don't have the tools, right? You can't use it all. So at the time you have to write in your own. So for that situation we have discussed about the construction of table. So let me combine both Yacc and legs file. See, these are all. So write the Yacc file, you'll get the .c and .h header files you can include. Now when you are writing the lexical analysis, as I told you now, even though the lexical analysis is the first phase, but when you call the compiler, the first phase to be compiled is parser only. So first Yacc file will be generated. That Yacc file will be incorporated to lex. Then by using the lex compiler, we'll convert it lex.yy.c. It includes both lexical analysis and syntax analysis. That's the meaning of it. YY, yet another. Then when you have given this .c file to the C compiler, it will give you the a.out. Now it is having both lexical analysis and syntax analysis. Now you give a plus b star c. First the lexical analysis will convert into id plus id star id. Then it will be converted to parse tree and it will tell you whether it is syntactically correct or not. So this is how a tool will be helpful in developing a compiler, just reducing the work of the developer. Right. So here we are having one more concept called error recovery in Yacc. So assume that we have an error here. Right. Set error mode, skip input while new line. Then what we can do, you can simply reset the parser to normal mode by calling the YY error. Okay. Here it is going to be terminated directly. Right, whenever you get an error, instead of that you can reset it to the normal mode by calling the YY error. Okay, like that we have so many other error recovery methods in the Yacc, but right, we have just gone through with the most popular error method. Right, so whenever you get it, then just we are recovering by using some appropriate message or by calling some error handling method. So this is about parser generator. So in this unit we have discussed about construction of all the parsers and parser generators. So in the next unit we'll discuss about third phase of compiler called semantic analysis.